My name is Ben Zotto. Today I'm here to talk about the Minifloppy revolution. The Minifloppy revolution by way of disk controller for the Sphere 6800 obscure microcomputer. That's the Sphere microcomputer, and this is its creator, a guy by the name of Mike Wise. It was built in Bountiful, Utah in 1975 and sold in 1975 into the beginning of 1977, and then the company collapsed, and then no one ever heard from them again. But it is an interesting computer, and I've spent the last few years researching, talking to people who worked at the company and digging through the history of the computer, the company, and the community of people around it. And so this is the brief pitch at the beginning. I have a book that is almost done that should be ready soon. If you're interested, you can check out, sign up for the little thing. There's going to be a little crowdfunding thing. It's coming soon. The book is called Go Computer Now, and it's about this computer, the Sphere. The Sphere is only sort of tangential to this talk. It's sort of a framing device because I have one, and primarily because this is a computer, it's an 8-bit Motorola 6800 system. And because it is from the era that it's from, its primary data storage is data cassettes, is audio cassettes, as you can see in the picture here. And the audio cassette standard for data and for programs for the Sphere, and this was typical of some of the computers of this time, is the Kansas City or byte standard. It was devised by a summit meeting of people who got together in Missouri in the early winter of 1975. And that stores data as serial frequency shift keyed audio, and it's quite slow. It runs at 300 bits per second nominally, which works out in practice to 27 bytes per second. 27 bytes per second is pretty slow. It gives you 1,600 bytes a minute, and it takes like a real long time to load like anything substantial. So you want to load BASIC, you push play, you go get some coffee, you come back, like maybe it's done, maybe there's an error. I don't know. I'm a modern hobbyist, and disks didn't really, the mini floppy disk didn't exist really at the time that Sphere was shipping these computers. But you know, I hear these great things are coming. These pint-sized floppies could replace cassettes in hobby computers and word processors. This is from October of 1976. So as a modern hobbyist, computer history interested person, I thought, well, these cassettes are inconvenient. I would love it if my computer could use floppy disks. And these pint-sized floppies, these seem very appealing. These have a 125 kilobit per second nominal data rate. That is 15,600 bytes per second. That is 15,625 bytes per second. That's 500 times faster than the cassette, more than that. And so I, as a hobbyist, go to, well, maybe I can use Flex on it. Flex is a CP/M-like standard operating system that showed up for the Motorola 6800 machines and some of the later variants. It was not around during the era that the Sphere was around. It's anachronistic for that system. But if you could get a disk running, maybe you get this operating system running, and wouldn't that be cool? So how might I hook it up? The Sphere system itself had a high-end version that came with a printer, and it came with a disk drive. And that was a very large, very heavy 65-pound disk system. And that was 65 pounds, sounds like a refrigerator. It cost as much as a nice new car back in 1975. And at the time for the Sphere, it turned out it could do almost nothing. So that's not like an interesting option for me. What I would like is something a little more svelte, a little more hip and aerodynamic. But to figure out how we got there, I want to talk about disk drives. And to do that, I want to talk about this. In the late 1960s, at the IBM research labs in San Jose, they were trying to figure out how to conveniently load microcode onto the IBM 370 mainframe and some of their related systems so they could do it without using paper punch tape. And so they had a team on this trying to figure out, well, we got these big magnetic tape drives, the things you see in movies with the fast spinning. We got those, high capacity serial access, and we have punch tape and we have punch cards. But what can we do that's sort of like a convenient middle ground to load stuff? And they're kind of tinkering around, and so they go out and they buy a 45 RPM record player. I don't know if it's this one, but this is one from the 60s, according to Google image search. So it probably looks something like this. And they replace the needle with a magnetic head, and they take a piece of the same material, more or less, that they got from that they use for the tape. Tape, it's like mylar with a coating of magnetic material on it. And they plunked it down on top of some foam rubber, on top of a record player. And they would save and load data off of this. And it worked, sort of. It kept having these little glitches that they called creepy crawlies, where every couple tracks, there'd be a little bump, and then the data would go out, but then the location would move from track to track. And eventually they realized that this is like a hair that's like under the thing that keeps getting bumped from track to track. So they start realizing that doing a open record-like system is not really going to work well. So they go to Safeway, and they buy some pink wipes. Pink wipes are these things. And they get some manila file folders. And they take the pink wipes, and they sandwich the disk material in between the pink wipes, and they put the manila file folders around that, and they make a little cartridge out of it. And that is the origin of the floppy disk. And it turns out that worked great. Well, the pink wipes themselves didn't work great, but then they found something more like a Kim wipe or a white thing that's a little bit better, and that was effectively the technology that we used throughout the entire historical run of the floppy disk. This is how they were constructed. That's the patent drawing for the original floppy disk assigned to IBM. It ended up looking mostly like this. There's a sort of middle bit that didn't really end up being practical, but you can see the wipe material, the magnetic disk, and then the jacket on both sides. They look like this. They're 8 inches on each side. Is there anyone here that's never seen an 8-inch disk? Is anyone like young enough? Cool enough? There we go. You're my guy. You're my guy. This is what they look like. They're huge. Amazing. I know. Mind blown. And the drive that they went into, the patent drawing looked like this. And this is the IBM disk drive. And you might notice in the abstract, it describes it as an interchangeable sealed disk cartridge that drops into a guide channel. And you'll notice it's sort of oriented vertically in this picture, and it refers to being dropped. And that's because the first use, once they figured out the microcode loading thing, they figured that was going to work good, and then they wanted to do a read-write version of it, because the microcode was just a read version. But they realized this is like a useful data storage for IBM's users, for their customers. And so they built a disk toaster. The IBM 3740, did I get that right? 3740 data entry system. And so you see how this works is you sit at one of these desks, and you have it's built into this desk is this floppy disk toaster mechanism. And instead of punching in information on punch cards, which was the standard prior to this time, you get to put those same records, because you're doing records on whatever your records are, your payroll, your accounting, your address lists, your whatever. Instead, you can do data entry, and you can save them to these. They were very excited about the fact that you didn't have to use punch cards, and instead, you could use these things. In the manual, in the installation documentation from IBM, they talk about it's more information than punch cards. Cards can be complete, you rewrite the diskettes. They're easier to handle. You can correct the information. The whole pitch was these things are better than punch cards in all these ways. But I will also draw your attention to the purposes of the diskettes. They were pretty prescient here. It was all about replacing punch cards in their IBM product, which was from 1973. But they were prescient about what you might use the disks for: storing data, buffering, process, storing and loading system microcode, distributing programs, storing and loading data, which is what we ended up doing, but that wasn't the original kind of use of them. So inside one of these jackets is this piece of magnetic material. That is a close-up of this, which is the mylar that sits in between the paperwork. Now, there are tracks and there are sectors of magnetic data on this disk. You can't see them with your naked eye, of course, because they're magnetic. But if you have a 3M magnetic tape viewer widget that's meant for, I think, audio tape or maybe data tape, and you look real close, you can see the tracks. Once they standardized this as the IBM 3740 floppy disk format, generally the simple format of this, the diskette 1, had up to 77 tracks, 27 sectors per track, 128 bytes per sector. And a sector is, of course, a unit of the disk, but to IBM, a sector was a record, and it's the replacement for the punch card. So you're saving one punch card's worth of stuff in one sector. A punch card typically had 80 characters, sometimes a little more. They set up these data entry systems so you could get the option, you could pay more, and you could get the option to do up to 128 character records, which of course are sectors. So if you maxed out the disk, the format wasn't quite like this, but you maxed it out, it's about 2,000 cards on one of these disks. And that's a box of punch cards. Punch cards came in these boxes of like 2,000 cards. So you can get like a box of punch cards. And it's really, I mean, it's way better. Okay, so you can't see the sectors on here, you can only see the tracks. Here's a screenshot of a Mac program called Applesauce that is a part of a wonderful sort of disk imaging suite of tools. And I love it because you can visualize this stuff really, really easily. You can see that it has done a flux image of this disk, and you can see there's the disk, those are the tracks, but those are the sectors. So those are you can see that we're sort of running out from the middle. Those are the 26 sectors, each is 128 bytes, and then there's 77 tracks. If you're looking for disk imaging stuff for a Macintosh, I strongly recommend this. I love it. The way that you can understand what's there is really helpful for if you're a visual person. Anyway, it was immediately imitated. So IBM invents it, and IBM sells stuff to their own customers, right? But everybody realized that this was very handy because everybody else was using paper punch tape and punch cards, maybe. So in the mini computer world, because at this time this is still the early 70s, so in the mini computer world, people are like, well, we should also make these. So Memorex is first out of the gate with a read-write 8-inch floppy disk. Memorex, also in the Bay Area, some of the people from IBM leave, go to Memorex. So there's this like group of people kind of moving around. But I want to talk a little bit about the history of Shugart Associates. And Shugart is a company that was founded by a man named Al Shugart. Shugart had been one of the tech leaders at IBM designing the 8-inch disk drive. Then he'd gone to Memorex, worked on a hard drive, and then he says, I'm going to start my own company and to bring all these people that I know who are already kind of expert in this technology. They're going to come with me, and we're going to do an OEM version of the 8-inch disk drive. So he wasn't the first, but they released the 900 series, and this is the 901. It's a 8-inch floppy disk drive. And then soon after that, the 800 series. And this is a Shugart 800 disk drive. And I know that we don't have that many people in the audience who haven't seen 8-inch drives, but this is a beast. This thing weighs 14 pounds. This is the Shugart device. It's made of cast metal. Like you can't break it. It would break, like it'll break your foot right before it will break. It's got a big AC motor on it, a big start capacitor. And I mean, it's a very sturdy piece of equipment. And Shugart didn't start off with the best reputation for reliability, but they gained it. They had pretty good engineering talent. They had these people who had been part of the floppy disk technology from the IBM era, so they kind of knew what they were doing, and they were ruthless about innovating. So they knew they made their own heads, the rewrite head, which turned out to be kind of like, that's kind of a specialty part. They made their own rewrite head, and they were willing to compete on price, and they eventually started soaking up market share. In 1975, about 50,000 disk drives, that's these things, by all manufacturers were sold. These numbers are tiny compared to modern computer numbers, right? But IBM had almost half the market, and IBM, of course, would only sell to IBM customers. They weren't building OEM drives for other people. So we had these OEM drives. Shugart was one of them, and Memorex was one. There were others that were also out there selling drives. In the OEM market in 1974 on the left, Memorex has the plurality, Shugart's number 2, Calcomp, Innovex, Orbis, Control Data, some others. Projected 1976, we can see that Shugart has swept forward, taken the lead. The big customers for these were the mini-computer companies who were building stuff with disk drives. DEC and Data General were both customers of Control Data, so Shugart was freaked out because those were some real big customers that they didn't get. But Shugart got Intel and got Wang, and they're also willing to drop the gross margin to, looking at the notes, in those days a disk drive was doing around 55% gross margin, which is like a bananas number if you know how this stuff works today. But Shugart was willing to push it down to 40 to undercut all the competition, and that's one of the ways that they kind of set up. And Wang kind of saved their bacon when they were really marginal. Wang became an exclusive, or they became the exclusive supplier to Wang. Wang Laboratories in Massachusetts, sort of a legendary firm, quite close to Digital Equipment Corporation and Data General. It was all in the 128 belt in Massachusetts. Wang was founded by Dr. An Wang in the early 50s. It became kind of a calculator company and then became a computers, and they're better known for like desktop mini computers and word processors. Dr. Wang himself was renowned for being one of the inventors of core memory. So he kind of founded this firm. Gets going, he's a big customer, he's Shugart's biggest customer. And his systems were these sort of desk-based things. So they had these had this terminal component, but like they'd sell you the desk. Like this was all you bought the whole thing from them. And you can see there's a disk drive. There's your 8-inch disk drive for you to save your work on. So Dr. Wang comes to Shugart one day and says, guys, we need to get a smaller, cheaper disk. I need you to come up with something for me, because what I'm trying to do is put a disk drive in one of my boxes, and I can't put this inside my desktop terminal. He says it's got to be smaller, it's got to be cheaper. I don't want to pay your OEM quantity prices. The OEM quantity price for these at the time was about $400. That's, I don't know, $2,500 today. And that's in quantity. And it weighs 14 pounds, once again. And he also said, it's going to be right next to a CRT, so I can't have the motor interfering with the display. And these have a very powerful AC motor that would not do well next to a CRT display. And so the Shugart engineers, they respect Dr. Wang. He's a legend in the industry, and he's also the biggest customer. So they're going to try and help him, but they don't love the assignment because there's no innovation here for them. All they're hearing is we want a cost-reduced version of the thing that we've already pioneered. And so they say, but it's Dr. Wang, so we're going to go do it. So they say, all right, well, we have our read-write head. We can just use that as is. And they're like, well, it should be smaller. Well, how are we going to prototype it? They take this, and they take scissors, and they cut it, and they make it smaller, and they put it back in the manila envelope, or they put it, back inside of a smaller one of these. And they produce essentially, and they have the data rate, and they slow down the motor, and they're like, all right, well, here's a junkier, cost-reduced version of our real product, and the result is this, the Shugart 400, which is the first mini floppy, the first 5 1/4 inch disk. It is, of course, so-called mini because this one is the real floppy, and for a long time in the writings and documentation of the era, when people talk about flexible diskettes or floppy drives, they're talking about these, and they'll make a point to differentiate if they're talking about smaller ones. That's a Shugart 400. I want to be really clear about the distinction between these two devices. This weighs 14 pounds. It sounds like a refrigerator. This weighs 3 pounds, substantially smaller. And the disk is these guys, which were much more common and were the ones that I grew up with. And you can see it's a lot smaller, but it's the same thing. They really just kind of built the same thing. Looking at the drive to see what's going on, there's this main spindle motor at the bottom. This is the bottom part of it. This big thing here is the stepper motor that moves you from track to track. From the top side, I've taken off the board that's on there, and you can see there's the clamp that the middle of the disc clamps into when you slide it in. That's the read-write head that goes back and forth. I want to draw your attention. I took off that the top frame, but I really want to draw your attention to this, which is a spiral cam disc. This was one of the things that the Shugart engineers were proud of because this was a cost reduction feature. So the way these drives work is they have a lead screw that's a carefully calibrated screw that clicks forward, and the read-write head moves on this tiny screw mechanism. They couldn't afford doing that, and they didn't really have the space, so they came up with this idea, which translates the rotation of the stepper motor into linear motion of the head. And you can kind of see what's going on. It's a little tricky, but this whole beige thing rotates, and this little pin is called a cam follower, and it sits in a groove. So as the whole thing rotates, the read-write head kind of slides back and forth. And they were pleased with that. And eventually it happened in other ways too, but this was what Shugart shipped in 1976. So Wang gets a new floppy disk. It's smaller, it's cheaper. The OEM quantity is at most $250, which is good for Wang. There's no motor interference. They decided to put a DC motor in, and now the DC motor is controlled through the interface. So the host system can turn the motor on and off as it needs. It's not running all the time. The downside, slower, half the data rate, and has less capacity, as you can imagine. But everything else is the same. The data density on the disk is, rather the track density is the same. The read-write head is the same. Wang put it into one of their revisions of the computer the next year. This is the Wang PCS2 from 1977. It's an evolution of the 2200 series, and you can see they just kind of balance the drives right there on top of the CRT. It's a very, very slick bit of industrial design. And then they started selling it more broadly to the market. Under the marketing, the gap is gone. It's the SA400 Minifloppy, and they trademarked Minifloppy, right? They were the first with this, and they wanted to trademark it. And so, not to be outdone, the other manufacturers called it the microfloppy, but it's the same thing. It's still a 5 1/4 inch drive, same form factor. They defined this form factor, which we knew for a long time after as a full height drive. It comes from whatever they came up with here. And everybody copied these guys. And because there was a clear initiator, which was not really true in the 8-inch world, everybody reused Shugart's interface. The actual connection and the pins on the back of the drive are the same on essentially all 5 1/4 inch disk drives. And then became the same on all the 3 1/2 inch disk drives. It's the same connector that Shugart cooked up for this, which was similar to their 8-inch drive, but was different from other manufacturers' 8-inch drive. It was a real Wild West. Anyway, it was a massive hit. Far beyond Wang, it was a sensation. Everybody realized this thing was cheaper, and the Shugart guys thought this is not the bleeding edge of technology. Who would want this thing? But it turns out nobody needed 256K on each disk. They could get 90K with some clever work, more than that. And that was like plenty for most uses that people had for these things. And you can imagine in your home or in your office which of these you'd prefer to have. Shugart, through the roof. They were kicking ass and taking names. Here's pictures of their laboratory, the read-write heads on the left, and then here's the production line showing the conveyor belt. So now we kind of get back to where the story from the beginning kind of comes back in, which is how am I going to hook one of these things up to my Sphere computer that never had an ability to talk to one of these? There's a component called the disk controller, and that sits in between the disk drive and the host software system. And you can see here the computer, whatever computer that is, has commands. It wants to read the sector's data. It wants to seek to a track. They're kind of these high-level abstraction commands of how to work with a disk. I mean, they're not super high level, right? But like they're high-ish level. And then there's a bunch of electronics called the disk controller that translates that into these low-level ideas like turn the motor on and off, step the head in, step the head out, and translate all the magnetic flux on the disk into a serial data stream. That thing decodes the serial data stream, sends the information back to the host system. And these were they were both their own business and they were expensive, as you can imagine. That's a disk controller. That's not two copies of one disk controller. Those two boards are one disk controller. That's like 150 chips or whatever. And they could go bad. They were expensive and they were complicated and they were large. When Shugart shipped their 400, they also shipped a disk controller that was meant to mate with it. They call it the mini streaker for reasons I've never been able to figure out. The SA4400, and that was a board that knew how to talk to one of these disk drives, and then would allow the host system to kind of do commands. There's a close-up of the two boards. These are by a company called ICOM. ICOM also made larger enclosed disk systems in which they placed these controllers in 8-inch systems. Here's an ICOM little advertisement snippet, and that's that pair of boards that you saw before. That's the controller. And they'd sell you this, and they called it the frugal floppy. For only $1,000, like $5,000, you could get a 8-inch disk drive. We're back to 8-inch drives, right? This is an 8-inch disk drive, a couple of these boards, which it's not inside anything. It's just like it's hanging out like this, and then a cable to your microprocessor. But the nice thing was then, if you had this, the commands were relatively simple. And there were several manufacturers that produced similar systems. So here's Synec Data Systems. The FDS2, similar idea. It's a couple of these 8-inch drives. And again, these things are huge. They're like 65-pound boxes, what you're looking at. And it had some hardware, and it would come with it. This was great. It's fine for the 8-inch drives. Well, fine. But you were already installing zillions of pounds of stuff in your computer system. But for these guys to really take off, it took this other invention. The company Western Digital, another Bay Area company, which specialized in large-scale integration chips, comes out also in 1976 with the floppy disk controller 1771. And that is a 40-pin chip that replaces all of the stuff on those controller boards. So before, we have these things in the middle that have to translate all these back and forth. And that's like, the OEM cost of that, a couple $100 easily. Or you can use this chip, $40, $60 in quantity at the time. So immediately, particularly for these drives, people are like, well, we want one of those. Like, we don't want, this is easy. So here's an example of a disk controller built with that chip. This is the National Semiconductor version of it, but it's the same chip. This is a Southwest Technical Products Corporation disk controller for the Southwest Technical Products Corporation 6800 computer. Not terribly dissimilar from the Sphere computer that I have and that I'm interested in. So you can see how few chips there are. Those chips are just kind of address decoding and some buffers and, I don't know, your basic board design stuff you got to have. There's the schematic for it, and you don't have to read schematics, but all you have to know is the thing in the middle is the 1771. The stuff on the left is the computer. The stuff on the right is the disk drive, and that's basically the whole thing. So I looked at that and I was like, well, I got a computer. It's kind of like a Southwest system, and I got the schematic. So why don't I just copy it? Great. So I cook up a little circuit board that is basically the same. There's that 1771 controller in the middle. And I'm like, all right, well, I'll copy the whole thing. I'll just do a little Sphere address decoding. It's a little different, but otherwise it's basically the same. Just to orient you, the Sphere, unlike well-designed computer systems, does not have an edge connector. I say that with all love. It does not have an edge connector to plug into a backplane. Instead, it has these 14-pin ribbon cable sockets. So the system bus runs on ribbon cables from board to board to board to board. There's no single board to plug things into. So I figured, all right, let's get going. The 1771, the way you program it is 4 registers. Usually you map them to 4 consecutive addresses in memory, or you do on a 6800 system. The command and status, that you send the command. When you write, it's a command. When you read, it's the status. Track register, what track do you think you're on? Sector register, what sector are you trying to read or write? And the data register, 1 byte at a time, read, write. I happen to assign them to these addresses in my system. And I'm like, all right, let's give it a shot. And I plugged it in, and it worked. The very first time, the drive head moved, and it read data. And I was like, I mean, of course, it was somebody else's circuit. I didn't design it. It was already known to work. But then I realized it didn't work. I thought it worked. But it turns out only 250 bytes out of my 256 byte sectors were actually showing up. And there's a special flag that the 1771 controller sends you called lost data. So I was like, oh, lost data, crumbs. Maybe it's a scrappy little chip. It doesn't buffer the whole sector. So unlike those controllers, you have to pull the data out of it one byte at a time. And you have to do it in a timely fashion, else. So maybe I'm not able to keep up with it. Let me figure out if I am. The way disks store data, mini disks, are all you can think about. It's read-write it's magnetic transitions. It doesn't read and write bits as such, right? It's just it's an electromagnet. It flips the magnet one way or another, and it does it every 4 microseconds. Microsecond is a millionth of a second. I say this to remind myself because I get confused. A millisecond is a thousandth of a second, and then there are 1,000 microseconds in a millisecond. If I'm wrong, somebody please. And nanosecond is another 1,000, but we're not going to talk about nanoseconds. So microseconds, so that every 4 microseconds, there's expected to be a transition or not a transition. You follow me? And we define that as a transition is a 1 bit and not a transition is a 0 bit. So if you had a byte, in this case, this byte, you're going to take 32 microseconds to store it, transition, not transition, transition, some not transitions, and then a transition. The problem is these motors, they're not perfect. They can change from system to system just a little bit, and these times are really short. So what happens is you can lose sync if you don't have enough transitions. The controller can get confused about where it is in the bit stream, and then you're in trouble. And so there's an encoding that solves this problem. And there are many encodings that solve this problem. They're very clever ones, but the simple one that was used on these very early systems is called FM encoding. And all that does is insert what's called a clock transition in between every data transition or not transition. What that means is there's never more than one not transition in a row. The other consequence, of course, is that it doubles the amount of time it takes to store a single byte. So here we have it's 64 microseconds. Those are the transitions that turns into in the disk. There's the serial data that comes up to the controller, and it's the controller's job to decode that, to figure out what is the clock and what is the data, and then produce that byte at that register. And how long do you have to get that byte? 64 microseconds. Every 64 microseconds, you got to pick that byte up, otherwise, lost data. So I go to my bit of code. You don't have to know how to read this. This is Motorola 6800 code. I'm like, this is the simplest possible loop for let me pull this data off of this controller. I'm like, is it not fast enough? There's the kind of setup, and then we're kind of looking at the status. Is their data ready? No, we're gonna keep waiting. Otherwise, we're gonna load the byte if it's there. We're gonna store it. We're gonna increment our pointer. We're gonna decrement the counter. Still more to go? Okay, go back and loop again. That takes 30 cycles on a 6800, or to my math. And on a sphere, where the cycle time is 1.5 microseconds, rather slow, that means it's a 45 microsecond operation loop. That's below 64, and actually rather a bit below 64. So that's not actually the problem. So get out the oscilloscope. That's not my oscilloscope. I wish I had one of those. And I probe around the disk controller, and finally it dawns on me. All this research for the book, and that I've been doing for years, and I realized that very few people got 5.25 inch discs working on their spheres. And I was like, well, they must not have been trying very hard. But now I know why. Sphere uses dynamic RAM. And this was a quite relatively new innovation. They were a very early microcomputer to use it. And DRAM needs to be refreshed. Refreshed just means you have to tickle it in certain ways to keep the capacitor bit charged. And the way that Sphere does it, there are cleverer ways in some systems, but the way Sphere chose to do it was to set a 2 millisecond timer, and every 2 milliseconds freezes the world, halts the computer. And it counts up some addresses that do the right RAM refresh, and then it lets the computer go again. Every 2 milliseconds. So if you trace the refresh line on the system, you'll see everything kind of pause briefly every 2 milliseconds, and then restart again. The problem is the length of the pause, 96 milliseconds. Now you remember 64 is how fast it's got to be. Do you see what the problem is? A sector is 256 bytes. 256 bytes times 64 microseconds is 16,000 microseconds or 16 milliseconds. And as you'll notice, 7 or 8 DRAM refreshes will happen during that time. You'll lose 7 or 8 bytes every time. So I realized that the free circuit that I got from Southwest Technical was not going to be helpful. Well, it's going to be helpful, but just the beginning. But I added some buffer memory to it. And so basically turning it more into like the sort of thing that those bigger controllers were, there's a sector buffer, which is like, okay, so you kind of stuff there are modes and you can kind of control the mode on the board. And it's like, all right, turn it into the mode where I'm loading the buffer, and then turn it to the mode where you're doing your own thing. And then very quickly, as the drive is running, or as the read or the write are running, it can pull from or it can write to the buffer and not the computer. And then when it's done, you kind of unlock the system, and then you can go in there and pull out the bytes that you need. So it got a lot more chips. Got a PIA there, the gold one, in order to help control the different modes. Got some RAM on the left. And I was like, I'm feeling pretty confident about this. I'm not an electrical engineer. And it didn't work. And it required some modifications to try to get it to work. And I was like, and after that I was like, well, I've got to fix now. This is the next version of it is going to work, right? It didn't. And this one required some additional hardware down on the breadboard with some, flying wires to get there. And I was like, well, after this one's going to work, and it didn't. So now we're on version 5, I think. But the problems became minimal. And finally, I got it to work. And with the buffered memory, I wrote a little driver for this Flex operating system, which is the 6800 standard operating system, and can boot Flex on this computer. It's an anachronism. It's a slight anachronism, but it is an anachronism. I am not the first person to have this happen. I know it happened in the sands of time in the 70s. There's evidence of it, but the way it was done was lost. Anyway, we found it again. So there's the board. There's a little boot ROM on there. We got a PIA. We have the 1771. It keeps showing up looking different, but it's all the same disk controller chip. And some memory and, bunch of other junk. So this Minifloppy became a really big deal. As you may know, it started showing up like everywhere. And all the home computers, all of which, like Sphere, started with really a cassette interface for saving and loading. That same calculus applied to all of them. Cassettes were terrible. I mean, it's a cool solution to a difficult problem, but fundamentally, they're a pain in the butt. And disks are like way, 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 way better. So here we have these other systems. There's the Tandy Radio Shack, the Apple, the Commodore, and these often started to use particularly clever ways of encoding the data beyond that kind of every other clock cycle thing to cram more data on there without violating that rule of too many no transitions in a row. In particular, the Apple with the Wozniak disk controller is legendary, and if you're interested in this sort of thing or puzzling out how you might do it, I encourage you to look it up. I don't really understand it. And then in 1981, the mini floppy disk shows up in the IBM personal computer. And this, as we know, kind of went and took over the world of business computing, substantially influenced the world of home computing. Now, these disk drives were not made by Shugart. These disk drives were made by a company named Tandon. And Tandon, which was founded by a fellow named Juggy Tandon, was an exclusive provider to IBM. They got the contract for it. These are double-sided disks. So in the IBM, the writing happens on the bottom, but also on the top, and there are two read-write heads, and getting that to work was really tricky. And Juggy Tandon got a patent on it, and everybody licensed it from him. And this was like his sort of huge contribution, but he sold, now they look exactly the same, you'll notice, right? Everybody copied the Shugart fascia, but they're not Shugart drives. Shugart themselves, this became commodity stuff. Shugart had been purchased by Xerox in 1977, right before their big peak. They did well for Xerox. Xerox kind of wrote them down and wrote them off by the early mid-'80s, and they were defunct by 1985. Alan Shugart himself, who in a funny turn had not been around for any of this stuff. Alan Shugart had been kind of pushed out of the company he founded right after he founded it. So the namesake company with the drives and everything, he had nothing to do with. But he did have a second act, an important one. He founded the company that is now Seagate, which is Shugart with the letters changed, which is still around just across the bay. He basically was the first 5.25-inch hard drive, I think, for PCs. That was his contribution. So he became a hard drive guy and had this whole very successful second career under the Seagate name. And that's where floppy disks went. Before I close, I want to acknowledge Larry Pesolo was a regular here at the Vintage Computer Festival for many years, both an exhibitor and an attendee, and a lot of people knew him. Larry passed away suddenly early this year, and I did an exhibit with him a couple years ago. He was a lovely fellow. He worked at NASA Ames in his job. He was frequently at the electronic flea market down at the college. He had many interests, many friends, and he had a good sense of humor, and he was a lovely guy. He is and will be missed. And I wanted to kind of put that on the screen. If anybody here knew Larry and would like to be in touch with his family, feel free to come and kind of find me afterwards. And with that, here's how you can contact me. If you're interested in a book about an obscure Motorola 6800 system and the people around it, check out gocomputernow.com. Otherwise, I have a bunch of resources at sphere.computer. You can drop me a line. This QR code is for the VCF survey. They would really appreciate it if you would do the survey, and they can find out how to make next year's VCF even better. Thank you. Does anyone have any questions? You don't have to.
Shugart did 4.7 business.
His pitch to investors was, I'm going to do like a computer. I'm going to do a lot of things. We're going to have a printer, disk drives, and computer systems. And I think because I know about disk drives, I think I can do these other things. And it took a long time to really get anything going. And the investors said, hey man, you got to focus on something. And he said, I'm not going to. Like I want to pursue this thing. And they kind of said, you're out. Yeah. And he went he went fishing for 5 or 6 years before the Seagate thing started. Seagate was started as Shugart Technology, distinct from Shugart Associates. But he did it in a ploy to draw a trademark lawsuit from Xerox, who at the time had purchased Shugart Associates. He was hoping to get the publicity out of a lawsuit, but he had to launch under the name. He changed the name too quickly to Shugart. But the stories are great. For stability. There was a company called Pertec made a competing or a similar drive, and they used aluminum, and it was sort of like the Shugart guys at the trade shows would walk up and like bend them on their table to like show the customers how flimsy it was. I don't know. I don't have enough experience myself to know if it was really that unreliable, but this really was the dominant mode in the 8-inch drives. And this is also a cast piece, although that's probably aluminum. I don't know. I don't have a perfect answer for you. Yeah. Stan?
So I have Pertec drives, and they don't like to be moved. I've just traveling in the back seat of a car up here to show it, and it needs to be realigned
Really?
on the floor. Yeah, it's particularly bad. They also don't like temperature changes because it expands and contracts.
There's your answer. Don't PerTech drive, don't move them, don't change their temperature. They're flaky. What you want, the beast. Thank you all so much for coming.
Thank you.